There it goes. Okay, so T is the time spent at the beach, and Y is the level of time that the person would get. And I mentioned that that particular level would be measured on a scale from 1 through 10. In a continuous sense, it's not discrete. I'm not going to say 1, 2, 3, 4. Rather, I use some sort of a device to measure the time, and that's what we have. I asked you to try and fit the line of best fit. Did we do it? Okay. Well, I said if you can't find the line of best fit, I said find at least the mean and the standard deviation for the two samples. Did we find that?
Yes.
Yeah.
Okay, good. So what is X bar?
T bar for T. Do you write it as like T
Oh,
bar?
thank you. T bar.
3.71.
8.75?
3.71.
Okay. Standard deviation for T?
1.80.
1.80. Y bar?
4.46.
Standard deviation?
2.46.
So those are the sample statistics, and we know how to get that. Plug it in the calculator, one variable statistics, and you would get the mean and the standard deviation. I call it T, which is why I put T there. You should correct me, but it could be X bar also. But that is the independent variable or the predictor variable, and this is the response. So we need to find the correlation coefficient first. Why? From last time, the line of best fit in this case would be Y equals beta 1t plus beta naught. And we want to estimate the values for beta 1 and beta naught. I made that awful joke last time. If we put a hat on top of it, it is an estimated value that we get from the sample. And I gave you a formula. Beta 1 hat is R multiplied by the standard deviation of the Y variable divided by the standard deviation of the X variable. The X variable is nothing but ST in this case, but I'll write the general formula. And beta naught, yes?
What is that one with the B?
This?
Yeah, what is that?
Beta.
Okay.
Like B-E-T-A. That is the correct pronunciation. Trust me. So those are just formulas. You don't have to memorize them. So we already know SY, which is the standard deviation of the Y sample. We know SX, which is the standard deviation of the X sample. And beta naught and beta naught hat and beta 1 hat are the estimators for beta 1 and beta naught, which we need to find. And X bar is T bar, which we know. Y bar is 4.46. So the only thing that's standing in the way is the value R. What does R stand for? Yes, Samantha.
The Y bar and the standard deviation for Y are wrong.
Did someone else try?
I agree.
Yeah,
Jesse?
they're different. My standard deviation for Y is 2.37 and my mean for Y is 4.85.
2.27?
2.37.
2.37 for this?
for the standard deviation.
Standard deviation,
And then for the mean, I have 4.85.
4.85. Okay, so 2.37.
2.38.
Okay. So 2 people vote for that one. Better.
I got the second.
This one?
Yes.
Okay. This one? Okay.
I have a question about the formula that you just wrote.
Yes?
So is R multiplied only by the standard deviation of Y, or is it multiplied by standard deviation of Y over standard deviation of Y?
Just standard deviation. It's in the numerator.
Okay.
It's a good question. What is R from last time? You can look at the notes.
The linear correlation coefficient?
It is the linear correlation coefficient. And what does that tell us?
The strength of the linear relationship between X and Y?
It tells us the strength of the linear relationship between X and Y. So what do we expect? Do we expect that to be positive or negative in this problem, even before we started?
Positive.
Positive. Why positive?
Because all of the numbers are positive?
Because all of the numbers are positive.
Because as the time increases, so does the level of tin.
So as time increases, the level of time also increases. So you have a positive relationship between X and Y. Last time I wrote a formula for R, which is 1 over n minus 1. And we wrote a table and did it using a table and such. But I'm going to show you how we can do this using a calculator. This way you can save some time when you do the homework and when you do the exam. If you recall, these two are constants and I simply pulled it out last time. So I'll do the same. Okay. So what I'm going to do is enter all the x values, which in our problem is the t values. So all the t values are 1.5.
Are the t values going in L1? Oh, my L1 already has everything in it, and I'm only getting rid of the numbers.
You can go to Start, press number 4, which is CLR list, which means clear list, and then hit second one. So the values are 1.5, 2, 2.5, 4, 4.5, 5, 6.5. Those are all the t values, and I'm putting those in list 1. And in list 2, I'm putting the level of time, 1.25, 2.9, 3.4, 5.6, 6.2, 6.7, and 7.9. Good. So exit out. The next part is not required. When you do the homework, perhaps they would give you a plot and ask you to input, but I'm just going to show you how to do a scatter diagram using a calculator to see if you would have a strong relationship between t and y. We already know that r has to be positive. I just want to see if I have a positive line and if it's going to be a strong relationship. So press second, y equals, and option 1. So it says on, off, we have to turn it on. The very first plot is a scatter plot. Second is a line graph. What is the third plot? Very good. What is the next one? Box whisker. That's another form of scatter plot. So enter. So automatically it populates list 1 and list 2.
Wait, which type are we doing?
The first one. Good. And you can choose the markings, whatever. You can either do a square, plus sign, or dot. I'm not worried about that. And hit graph, and you get something like that. So, do you believe that this would form a good line?
Yeah.
Think so? So if you look at it sort of this go like that, right? Which is better, a line or sort of a curve? It seems like a curve, but we're going to try and fit a line. Let's see what the value of r is going to be like. That's going to tell us if it's going to be a strong linear relationship or not so strong linear relationship. I'm assuming a linear relationship, so we have the picture. Now we just have to do this part. Now I entered all, yes.
Can you go over how to get to the graph again?
Press second, y equals, that should say start box. Do you see it?
Yeah.
Number 1, turn that on, down arrow, select scatter plot, and the rest the calculator would do it on its own. X would be L1, Y would be L2. By default, X is L1 and Y is L2. So we saved all the X values in list 1, yes, and all the Y values in list 2. Correct? We already know the mean for each of them. So what I'm going to do is go back to the calculator. I don't want you guys to do this manually. This will save you a lot of time. So open paren, second 1, that's going to gather all the X values minus what is the mean of X or T bar in this case. It is 3.71. Multiply by all the Y values. I've saved it in list 2. So second 2 subtract the mean for y, which is 4.85. Good. Close parent, and it is going to take care of this entire part for every single value of x and y. Good? So if I enter, it's going to spit out those values onto the screen. But I don't want to do that. What I'm going to do is I'm going to save it to the third list in the calculator. You can easily do that by pressing the STO button, which is right above the on button. It's right there, STO. Any guesses as to what STO stands for? Storage, very good. So store. So I'm going to say evaluate that particular expression, which is what we have inside here, and save it to the third list.
Now do you press enter?
Good? With me? Now press enter. And it is spitting out all the values for us, 7.956, 3.3345, and so forth. Let's verify if it is there in our table, and it is there. Those are the values, so you can verify it. 1.5 minus the mean for x, multiplied by 1.25 minus the mean for y, that should come to 7.956. Do we get those values? Yes? Okay. Now I have to sum all of them, correct? But instead of doing it manually, we know how to get the sum of values in a list. This is like 3-4 weeks ago. How do we get the sum of all values in a list? It's not clicking. Start, over to calc, one más task. I would like to sum all the values in the third list, so I'm going to press second 3. If you have the newer model of the calculator, you have to put L3 in list, hit enter 1, then hit calculate. You can go back and watch this video also. I'll post it over the weekend. Enter. You tell me, what is the sum of all the values in list 3? 25.225. So I have that answer. So R would be 25.225 divided by, what is n minus 1? I have 7 observations. 7 minus 1 is 6. What is the standard deviation of x? Not this one, over here. 1.80. And the standard deviation of y is 2.38. Go ahead, evaluate that and tell me what you get. Three six.
Okay, I got 18.
Yeah, same.
18.01.
Parentheses.
Yeah,
So,
I put parentheses. I don't know how it happened.
so, let me see. You didn't put parentheses. So this entire thing has to be in the denominator. So
Yeah, it's in the denominator, see?
no, when you do it that way, it's going to divide 25.225 by 6 and then multiply by these two. So you have to put another set of parentheses. Do you see those memes in Facebook and whatever things that you use these days? Oh, solve this, what is the answer to this with division, addition, subtraction, and people would fight over that?
Yeah.
Okay. If you know something called operator precedence, it's quite simple. But the issue here is, even if you give the correct answer, people would not listen. They'll fight with you. That's when you just say goodbye and have a glass of wine or juice. Okay. We know the value of R now, which is 0.9814. So do we expect a strong relationship, a strong linear relationship? I shouldn't say expect. Do we see a strong linear relationship? Yes. So multiply that by the standard deviation of y, which is 2.38, divided by standard deviation of x, you get 1.8.
Oh, the micro.
Standard deviation of x. 1.6.
So how do you input it into the calculator? Do you just add another set of parentheses?
For the value of r. Or you can do this. Evaluate the denominator first, then divide the numerator by whatever you evaluate. Do it in 2 steps. What is the answer? $297, you say?
2976.
I'll keep things simple. Well, it's fine. We'll call it 1.3, and I'll put approximately. On an exam or when you do the homework, keep up to 4 decimal places. The more decimal digits you have, the more accurate your answer will be. Okay? Now that we have beta 1 hat, the formula for beta naught hat is y bar minus the value of beta 1 hat that we found, multiplied by x bar. Y bar is 4.85 minus the value we found, which is 1.3, multiplied by 3.71. And what do we get? Point six? Maybe less than that. 2.9. Huh?
0.027.
0.027. It's very, very small. Good. It's not the ways. It's R. So we have the value of beta 1 hat and beta naught hat, so the line of best fit. Beta 1 hat multiplied by t, which is our x variable, plus beta naught hat 0.027. And most frequently, in undergraduate text mostly, we put a hat over them and describing that equation. y. So whatever weight value that we have here for beta 1 and beta 0 are not written in stone. Do you agree? If I collected a different sample, I might get a different answer. So these are just estimated values. So whatever t I plug in and whatever y value that I get is also an estimate. It is not written in stone. Do you agree? So that's why we put a hat up there. With me? Okay. So that is our line of best fit. So those are the t values or the x values. From the sample, we have 1.25, 2.9, 3.4, 5.6, 6.2, 6.7, and 7.9. And now we have to find the fitted values. In other words, we have to take each value of t and plug it in the line of best fit that we found to get y hat. Good? Again, we don't have to do this manually. We can use the calculator. I don't know if you guys did this in algebra. You can evaluate an entire equation one value at a time by going to y and put 1.3 instead of t, call it x.
The screen.
Oh, sorry. So 1.3 instead of t, let's put x, plus 0.027. That is our line of best fit. Good. So second mode and exit out. And you see window over there, and right on top of it you see TBL set. That stands for table set. It defines how to set your table. Press second window, and you're going to set up the table. We will say let's start at 0. Delta TBL is the increment by 1. You can ignore that. The key thing here is to go to INDEPENDENT. What could that stand for?
Independent.
Independent. Switch over to ask. Good. And second mode, exit. Second graph. So we have x values to enter. The calculator is waiting so that I can enter these values. When I enter 1.5, I get 1.977. Let me just call it 1.97. So I'm going to plug in each value of t. When I plug in 2, I get 2.63. When I plug in 2.5, I get 3.3. When I plug in 4, I get 5.2. When I plug in 4.5, and 5.9. When I plug in 5, I get 6.5. When I plug in 6.5, I get 8.5. So the y values are from the data. The y hat values that we found are from the line of best fit. So whatever values that we computed are computed using the line of best fit that we found. So these values that we plugged in the line of best fit to estimate the value of y are called the fitted values. And the data is typically called the actual value. That's just statistical jargon. So the given data for y are called the actual values for y. Whatever x value we plug in and estimate the value of y would be the fitted values for y. Good? All clear? Save this. This is important for the next time. Have a good day and a good weekend. If you have any questions, do talk to me.